All right, this video is going to help us understand how to evaluate a polynomial. There's two major ways to evaluate. The first is direct substitution. It's probably one you're the most familiar with. The downside of direct substitution is you sometimes have to deal with large exponents. But the upside is it's fairly easy to set up. If I want to find f of negative 2 given f of x, what I can set up is that 5 times negative 2 to the fourth will be my first part of my term. Again, I'm taking out x, plugging in negative 2 where there used to be an x. So I'll do that same thing for each one of my terms. Taking out the x from x squared, calling it negative 2, taking out 2 times x, calling it 2 times negative 2, and also don't forget your constant term. Now the downside, as I mentioned, is that we're going to have to find those exponents. Now 2's to powers aren't very bad, but you may not be familiar with some of those higher numbers with higher exponents. Negative 2 to the fourth, again, negative number to the fourth power is an even exponent, so my negative is going to disappear, and 2 to the fourth is 16. Negative 2 squared will be a solid positive 4, so I'm going to still say minus 21 times 4, and notice we're also going to have to multiply some larger numbers. Unfortunately, that's kind of unavoidable. But finally, we can put together our last terms. So this essentially becomes 80 minus 84 minus another 4 minus 25, and 80 minus 84 is negative 4, minus another 4 is negative 8, minus 25 would be a negative 33. Now let's go down here to what's called synthetic substitution. The nice part about synthetic substitution is you won't have to deal with those exponents. It also means you won't have to deal with multiple terms at a time. It really kind of has more flow to it. It's more of a one thing at a time kind of a deal. If you're finding f of negative 2, what we're going to do is put negative 2 up here in a box. Okay. Then I'm going to put a summation bar here because we're going to basically be multiplying and adding. That's the real key to synthetic substitution. It's all about multiplication and addition. Multiply and add until you're all out of numbers. Now, the other thing you need to remember about it is when we grab our coefficients, the key to synthetic substitution is I'm just going to grab these coefficients out of my terms. So 5x to the fourth, what you need to remember is you need to represent all terms, including from term of highest degree all the way to constant. So if there is no x to the third, we need to fill in a 0 in the place of x to the third. So where this was x to the fourth power, we've got our x to the third power here as well. Now I need to have x squared, x to the first, and my constant. Now you don't have to write the x's in there normally when you do synthetic substitution, but it's not bad to kind of keep track of what you're doing. Again, it was negative 21 x squared, a 2 x to the first, and negative 25 was my constant. Now, like I said, these x's really don't have anything to do with my actual substitution right now. Now all I need to do is follow the numbers. So first things first, I'm going to take my first number and I'm going to drop down that 5. Now I multiply by the number in the box. Negative 2 times 5 is negative 10. Add the two numbers together, giving me again negative 10. And negative 2 times negative 10 is a solid 20. Add them up again, giving me negative 1. Then we're going to multiply by 2. And you're going to just add from there, multiply again, and then finally add together and you've got negative 33, which you'll notice was the solution that I got up top. Therefore, finding out that f of negative 2 is equal to negative 33. On the next page, I've got a different polynomial for you. So why don't you go ahead and take f of x and see if you can find f of 3 both directly and synthetically, and I'll be back with you in just a few seconds. Okay, as far as direct substitution, remember you're just filling in the numbers, so we can just say that that's 3 to the fifth, which again is going to be a fairly large number, minus 3 to the third, minus 3, minus 10. 3 to the fourth I know is 81. 3 to the fifth then I believe, you can double check my numbers, is 243. Again, even I'm not that familiar with those larger exponents because they just get really big. They're really tedious to work with. 243 minus 27 would be 216 minus another 13, or basically I believe we should end up with 203. Let's check our answer with synthetic substitution. Again, we're going to take that 3, we're going to put it up in the box. We're going to take all of our coefficients, so 1x to the 5th, notice 0x to the 4ths, minus x to the 3rd, again 0x squared, minus 1x, and a negative 10 for the constant. So we've got to work our way all the way down there. Now we just start the process. Drop that first one, multiply it by 3, add to 3, multiply by 3 again, adds to 8, multiply by 3 one more time, add them up again, times 3 is 60, becomes 72, add them up, becomes 71, and if we multiply by 3, that's going to become 70 times 3 is 210, and times 3 and 1, I believe, is 213. Subtract your 10, and notice again we get that nice 203. Best way to write our answer again is to sum up what we just did. We found that f of 3 equals 203 for our final answer. I hope that helps you with synthetic substitution. Good luck and have fun.